today's notes are going to be about simplifying radicals. So when I say the word radical, I really just mean the name of the square root symbol. It actually has a name, it's called a radical. We don't just say square root symbol because you don't have to just have a square root. You could have a cubed root or a fourth root or a fifth root. So radical is literally just talking about the simple shape, not actually the type of root that you have. When we simplify radicals, you're going to be looking for two things. You need to be able to list the factors of the number you're trying to reduce or simplify. And you need to make sure you watch out for perfect squares because that's how we're going to be simplifying them. Quick refresher. A perfect square is simply a number that when you take the square root of it, you get a whole number. So 25 is a perfect square because 25 is 5 times 5. So the square root of 25 is 5 because when you multiply 5 times itself, you will produce that 25. So 14 times 14 is 196. So the square root of 196 is simply the number 14 because when you take 14 times itself, that's when the 196 comes into play. Again, square root of 81 is 9 because 9 times 9 is 81. You've done square roots and perfect squares especially for a long time, but we're just refreshing. Now, sometimes things are not perfect. They're not super easy. You're going to get a decimal. The square root of 20 is 4.472 blah, 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 blah times 4.472 blah, 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 blah. We're not expecting you to know that. So since we're not human calculators, we write things in the simplest form called radical form, and you just do the best that you have to, that you have to work with. So 75, for example, is 8.66 times 8.66, but no one's expecting you to know that. So we're going to write it in a different way instead. Now, how do you do that? Quite easily. It's going to be a simple 3-step process. Step 1, list all of the factors of what you're working with. So for example, 75 is 1 times 75. 2 doesn't work beautifully. It gives you a decimal. So we're only working with the beautiful numbers. No decimals required, which is really nice. Now we know that 75 is also 3 times 25. 4, again, produces a decimal. When you divide 75 by 4, it's not beautiful, doesn't go in evenly, so we skip it. 5 times 15. 6, 7, 8, 9, 10. None of those are going to be beautiful. Even 10 would be 7.5 times 10. So that's not going to work. And because it wouldn't want decimals. 11, 12, 13, 14, all those produce decimals as well. And then you get to 15. When you do the 15, goes into 75 5 times, you've repeated yourself, so you know your list is done. So once you've done all of the list of your beautiful sets of factors, step 2, pick the set of factors with the biggest perfect square. 1 is a perfect square, sure, but 25 is way bigger. So we're going to pick 25 times 3. That's still 75. We're going to put it underneath the radical. 25 times 3. That's still the same thing, so you're allowed to do this. It's still equivalent. And that leads us to step 3. How we're going to simplify. We're going to reduce this radical to simplest form by taking out the perfect square. We've already refreshed that the square root of 25 is 5 because 5 times 5 gets you back to 25. So all that's going to happen is you're going to take whatever's beautiful out of the radical, out of the house, and you're going to leave whatever isn't a perfect square, back inside the house. That's it, the radical being the house. So 25 comes out of the house, and it comes out of the house as 5 because the square root of 25 is 5. 3 stays home. That's it. The square root of 75 is the same thing as 5 times the square root of 3, 5 root 3. Now typically we write this a little bit closer, but it doesn't actually matter. I wasn't really paying attention. If you put 5 times the square root of 3 in a calculator, you will get 8.666. Promise. So moving forward, let's do those same 3 steps again with another number. Let's make sure we get it. So step 1, list all the factors. So 12 is 1 times 12, 2 times 6, 3 times 4. 5 doesn't work. It's not beautiful. It has a decimal. Whenever you multiply or divide, we don't want to do that. Then we're back to 6. We repeat ourselves. We know our list is done. So step 2, pick the set of factors with the biggest perfect square. Well, 1 versus 4. 4 wins. So we take 12 and instead we write it in a different way. 4 times 3. Step 3, reduce the radical to simplest form by taking out the perfect square. The square root of 4 comes out of the house as 2, and the square root of 3 stays home. So the square root of 12 is the same thing as 2 root 3. That's how we say it. Now you can say it lots of ways. 2 times the square root of 3 if you want to get really technical about it. But a quick 2 root 3 is understood to be the same thing. Okay, let's do it without the instructions this time. 500. Step 1. List all of your factors. 1 times 500. 2 times 250. 3 does not go beautifully. 4, let's see, 4 goes into 5, that would be 125 times. So 4 times 125. 5 times 100. Eventually, you'll do 6 and 7 and 8 and 9 and 10, and maybe they have a beautiful scenario, but I kind of already found my perfect square. Now you can keep going and you can keep telling me stuff like 10 times 50, 25 times whatever. There are tons of perfect squares in this one, but I actually already knew I found it because if you look at this list over here, since I'm going in order, from all the way from number 1 to, increasing in value, what I'm noticing about this side is that it's decreasing. And when I look at the perfect squares, I spotted a perfect square. So really what it boils down to this way. If you do it this way and you list your factors, more often than not, the first perfect square you see on the right-hand side, the right-hand column, is going to be your biggest one. So 5 times 100. So 500 is 100 times 5. You do not have to put the 100 first. You can put the 5 first. But I do this because I want to make a visual where you see that I'm taking the square root of 100, which is 10, and then the square root of 5 stays home. Now, notice that you know that you're completely simplified because the square root of 5, there's no perfect squares in that. That's just 1 times 5. So what's left over can't break down any further. That's important for you to notice. So a couple more. We're not going to do a bunch of these. We already did 75. That was the first example. Sometimes you have perfect squares where it's literally just the answer. So the square root of 36 is just 6. No crazy radical left over. The square root of 16 is just 4. The square root of 64 is just 8. If you do not remember your perfect squares, I want to highly encourage you to refresh those perfect squares. We're going to do 2 more. We're going to do the square root of 80, and then we're going to do the square root of 30. So when you look at the square root of 80, let's zoom in on that just a little bit. This one is important for you to notice. Here's why. You've got 1 times 80. That's a little thick. Okay. 2 times 40. 3 isn't beautiful. 4 times 20. 5 times 16. 6 isn't beautiful. 7 isn't beautiful. 8 times 10. 9 isn't beautiful. we're done. 10 is 10 times 8. We're repeating ourselves, so we're done. When you look at this list, technically 1 is perfect, 4 is perfect, and 16 is perfect. So we know that we need to pick the biggest one. So we're going to pick 5 times 16. 16 times 5. The square root of 16 can come out of the house as 4. You end up with 4 square roots of 5. 2 things I want you to notice. 1, this 4 does not become a 2. You've already taken it out of the house. Just because what's left over is a perfect square does not mean you take it further. Once it's out, it's out. Leave it alone. You've already simplified it. And 2, if you pick the wrong pair, let's say you chose 4 and 20, I want you to notice that you can still work your way to the right answer. The square root of 4 comes out as 2. But when you look at 20, there's another perfect square and its factors. So see, it's really important for you to pay attention to what's left over and make sure nothing can further come out, because then you wouldn't have had simplest form to begin with. So if I take the 2 that's outside and instead I make 20 4 times 5, 4 times 5, this 4 comes out of the house and it's another 2, and that's multiplication. So it joins it. And oh, look at this. 2 times 2 is 4, and we still have the square root of 5 left over. So you can still work your way to a correct answer. The last one is the square root of 30. Sometimes nothing's beautiful. 30 is 1 times 30, 2 times 50, 3 times 10, 4 doesn't work, 5 times 6, 6 times 5, you start repeating yourself, you know you're finished. And none of these are perfect squares other than a 1. And why would you take out a 1? No one's going to actually, like if you think about it, 1 times 30, and the square root of 1 is 1. 1 times the square root of 30 is still just the square root of 30. So there's nothing you can do on this one. It does not simplify. There is nothing wrong with that. Something to be mindful of.